I'm Kirti Sharma from 1BSCDS. My registration number is 22112017. I'm going to explain you the topic selection operation with my partner Michelle D'Souza. Handing over to my partner.
Hi, my name is Michelle D'Souza and I'm from 1BSCDS. My registration number is 22112022 and I'll be talking on the topic selection operation with my partner Kirti Sharma.
Damn it! What happened, Michelle?
I can't get this. I'm trying to do selection operation but I don't know how to do it.
Oh, the N-ary selection operation?
Yeah.
Oh, it's quite easy. Oh, let me explain it. Okay. So basically what a selection operation is like, essentially it is when we have to select some particular data from a given N-ary relation. Like we have a given N-ary relation and we have to select a particular data based on some condition. So what we are doing, we are selecting some particular data from N-ary relation and making a new N-ary relation. Or like, did you understand what I said?
Maybe if you do it then I can understand.
Okay, let me give you an example. See, this is our example. Or in the formal language, let's see we are requirement that each element in R, like R is an N-ary relation, must meet to be an N-ary relation. The selection operator SC converts all n tuples from R that meets the requirement to new N-ary relation mapped to R.
Oh, okay.
Yeah, and you can see this. This is the structure. This is the set builder form of an N-ary relation. So should I give an example or you want to do it by your own?
Selection operation. Selection operation is essentially selecting some particular data from a given N-ary relation, or we can say that selecting or making a new N-ary relation from a given one. So this is a casual language to explain what a selection operation is. But if we want to see in the particular formal language, so let C be a requirement that each element in R must meet, and let R be a N-ary relation. The selection operator SC converts all n tuples from R that meets the requirement to a new N-ary relation mapped to R. And if you want to see the set builder form of it, so if R is N-ary relation to set A, A1 and A2, so our R1 could be the new N-ary relation which is going to become after the selection operation. So R1 equals to A, B, C ordered pair such that A, B and C satisfy a condition where A belongs to A, B belongs to A1 and C belongs to A2.
So this is the example that we'll be working on. As you can see here, so R1 equals to order pair of A, B, C, D, such as D is greater and equal to 3.45, where the A is equal to name, B is equal to metric number, C is equal to department, and D is equal to GPA, where A belongs to A, B belongs to B, C belongs to C and D belongs to D. Application of the selection operator SC, where C is the requirement that D, which is equal to GPA, is greater and equal to 3.45. So as you can see, after we put in the requirement, we have got the data that satisfies GPA of 3.45. So from this, I understood the selection operation, but did you?
Hello, my name is Shubhangi Pawar. I am from BSCDS department and my register number is 22112038, and today I am going to talk about projection operation with my partner Sanjana, and I am passing over this to Sanjana.
Everyone, my name is Sanjana Gupta. I am from first BSCDS, registration number 22112026. I am here to talk about the topic projection operation with my partner Shubhangi.
Hi Shivani. Hello Sanjana. What are you doing? Actually, I'm trying to understand projection operation, but I'm unable to understand that. Will you please help me with that?
Yeah, sure. It's not that hard, okay? It's like you can solve it. If I explain you, maybe you'll understand. So, see, basically, projection operation Okay, so projection operation is basically represented by phi. It is a unary operation. Okay, in relation algebra that performs a projective operation task. So it projects, displays the particular column or attributes from relation and deletes it that are not in the projection list. So it basically deletes the things that we don't want. Okay, it is represented by phi, as I told you before. Duplicate rows and columns are eliminated from the results. Notations that we use here. So we use phi, a1, a2, and so on till an. R is also used here. An are attribute list, and R is a relation algebra or relation name. For example, I'll explain you with an example so it will be easy for you to understand. Okay. So consider the following students' relation on which the projection operation will be applied. So example, we have ID, name of the student, subject we have, and the age of that student. We have different ages and different names here. So this is the table of the student. So query comes here is display name and age of the student. So what we'll do here is we'll write phi name, comma, age of the student. Then we'll get the name and age of the student. Like if, for example, if you want the name and age if you want only the name and age of the student, so you'll just write name and age of the student. That's all you need to do.
Okay.
Did you understand it?
Yes. Okay, I understood that.
Okay. So this is the query question. Explain me how would you solve this?
Okay, for the question display ID and names of the student, I will choose phi, then the ID and the name of the students. So the ID and name of the students will display. Yeah, and the remaining rows and columns will get cancelled.
There are some important points. If you go through this, I'm pretty sure you will understand it in a better way.
Okay, sure. I will definitely go through this. Thank you.
Hi Karan,
How are you?
I'm good, how are you?
Yeah, just fine.
Tell me, what's going on?
Bro, I'm just facing some difficulty with my CIA assignment. Can you help me with that?
Yeah, sure. What is it?
I have a CIA of joining multiple tables into one. So I'm facing a lot of difficulty with that. Can you help me?
Yeah, of course. Have you heard about join operations?
No,
So
haven't.
basically, if you have two or more tables and they have some identical data in it, you can join them using join operation. So it's easy. You should try it. Do you
That-
know how to do it?
that means it combines two tuples or rows into one relation.
Yeah. You can do that easily using a join operation. It's easy. So if you want, I can give you an example. Will you understand? Yeah, it will let you understand.
Yeah.
Okay.
Join operations.
And its types.
So what are join operations? The join operation is used to combine two tables into one when these tables share some identical fields.
It combines tuples or rows from two relations into a single relation based on a given join condition. It combines related tuples from two relations into a single relation.
For example, we have depositor here, and in depositor table we have ID, which is 1, 2, 3, and in name we have A, B and C.
We have the second table as borrower, in which we have ID 235 and name BAD. So now we'll take the Cartesian product of these product of the depositor and the borrower table, and whichever row or tuple share the same identical fields, we join them together.
Okay, so as the intersection of depositor and borrowers are A and B, we have taken Cartesian product operation. It combines R1, which is relation 1, and relation 2 without any condition. It is denoted by X. Degree of R1 and R2 is equal to degree of R1 plus degree of R2. So basically degree is the number of columns that we have in our table. It combines the relation 1, R1 and relation 2, which is R2, with respect to a condition, and it is denoted by this symbol, which you can see right here. The different type of join operations are as follows. So first is theta join, second one is natural join.
Third one is outer join, and subtypes of it are left outer join, right outer join, and full outer join.
In theta join, if we join R1 and R2 other than the equal condition, then it is called theta join or non-equi join. For example,
we take a table like registration number, branch and section. In registration number we have 1, 2, 3, 4, 5. In branch we have CSE, ECE, Civil, IT and IT. In sections we have A, B, A, B, A.
Name and registration number. Name is Bhanu and Priya. Registration number is 2 and 4. R1 join R2 with condition R1 and registration number which is greater than R2 registration number.
So after joining R1 and R2, we get the following table. So in the join operation, we select those rows from the Cartesian product where R1 registration number is greater than R2 registration number. Join operation is equals to selection operation plus Cartesian product operation.
In natural join operations of N-ary operations, we have a table, and if we join R1 and R2 on equal condition, then it is called natural join or equi-join. Generally, join is referred to as natural join. Natural join of R1 and R2 is as follows. We select those tuples from the Cartesian products where R1 and a registration number is equal to R2 registration number, so R1 join R2.
Outer join operations. In this we have table R1 and table R2, which contains R1 contains registration number 1, 2, 3, 4, 5, branch CSE, ECE, Civil, IT and IT, section A, B, A, B, A. Table R2 contains name Bhanu, Priya, Hari, registration number 2, 4 and 7.
So here we can see that table R1 and R2 have a registration number in common, and now we'll talk about left outer join operations. So here we'll take the table and left outer join operation. It is denoted by R1 join R2. Here all the tuples of R1 which is in left table appear in output. The mismatching value of R2 are fulfilled with null, and left outer join is equal to natural join plus mismatch slash extra tuple of R1.
Right outer join. In this we have a table of registration number 2, 4, branch, section, name Bhanu, Priya, Hari, registration number 2, 4, 7.
So here the empty cells are filled with dash or nulls. It is denoted by R1 and R2. Here all the tuples of R2 which is in right table appear in output. The mismatching values of R1 are filled with null, as we can see it here. Right outer join is equal to natural join plus mismatch slash extra tuple of R2. In full outer join operations, we take the left which is here and second one is right outer join together to get a full table of all the cells filled with registration number, branches, section, name and registration number. Now the common areas which were satisfied are taken together, and which were not are filled with nulls and dashes. Thank you.